Hello people, and welcome back to another math video, this time on direct variation, also known as if this changes, so does that. Alright, let's get started. Direct variation sounds really fancy, but really what it means is that when one thing goes up at the same rate, the other thing goes up at the same rate. For example, eating donuts. If I sit down and eat donuts, and over time I eat more donuts, every 2 minutes I eat another donut, then that's changing. Time is going up and the number of donuts I'm eating is going up. And if they go up at equal rates and their ratio is proportional, we would say we have a direct variation. Another way to think about direct variation is to think about buying something. If I'm buying pizzas and one pizza costs $8, two pizzas would cost $16, three pizzas would cost $24, four pizzas would cost $32. This is a direct variation. This value is changing at the same rate, going up by 1. This value is changing by the same rate, going up by 8. So I have a direct variation. Sometimes with direct variation, we'll hear the phrase that y, and that means like this y, varies directly with x, like this x. Well, what that really means, an example with the cost in the pizza, is that my y value, which is the cost, directly varies or directly changes with the x value. Well, this really makes sense. That means that my cost is going to go up or change directly with the number of pizzas I buy. In some ways it seems so simple, it's like almost hard to explain. Yes, of course the cost goes up if you get more pizzas. It's not like if you get more pizzas the cost would be less money, right? So yes, this is going to go up. Okay? If I order more pizzas, they will cost more money. Today we talked about this equation, y equals kx, and we read it by saying that y varies directly with x. So really, written as the equation, y is equal to x times k, and k being kind of this constant for how much it varies. So y changes directly when x changes, and the k is kind of telling us how much. And we had problems like this. If y equals 38 when x equals 6, then find y when x equals 20. So what we want to do is first write this equation that y equals k times x. Y is varying directly with x. And then we're going to plug in the values that we know. So the first one we get is that y is equal to 38. Okay, so I'm going to substitute that in, 38, and x is 6. I don't know what k is yet, so I'm doing k times 6. So what this is really saying is that the number 38 is equal to some number I don't know what it is, times 6. So now we just have to isolate k, get that by itself. Well, right now we're multiplying by 6, so if we divide by 6, then these will cancel. And whatever we do to one side, we need to do to the other side. So I know now that k is equal to 38 divided by 6. So if I just do 38 divided by 6, I get 6.3 repeating is what k is equal to. So now this is important because now I know the value of k. So this next part, I'm done with that. This next part says find y when x is equal to 20. So I don't know what y is. Here's my equation again, y equals kx. I don't know what y is, but I do know what x is. That's 20. And I learned what k is. 6 and 3/10 repeating. So now y is going to be equal to 6.3 times 20. So y is equal to 126 and 6/10 repeating. Okay, here's two different problems. For both of them, here are the directions. If y varies directly with x, write the equation for the direct variation and then find each value. Okay, so first off, we've been told that y varies directly with x. So we need the equation that shows that. Here it is. Y equals kx, meaning that y is equal to x times a certain number. And that's going to be, so they give us this, y equals 20, so I'm going to substitute in 20. I don't know what k is, but I do know that x equals 8. So now I can just get k by itself by dividing by 8. Do the same thing over here, and if I divide 20 by 8, I get 2.5, so k is equal to 2.5. So now, the next part, I did my first part, so I'm done with that. Find y if x is equal to 12. So we'll just set our equation up again and plug in the values that we know. Now we don't know y, it's asking us to find that. Do we know k? Well, yes we do. K is 2.5 in this case, so y is equal to 2.5 times x. Well, x, they're telling us, is 12. So 2.5 times 12 will give me the value for y. 12 times 2.5 is 30. So in this case, y equals 30. Alright, here we have another one. If y equals 40 and x equals 15, alright, we know it varies directly, so we'll set up our equation again. Y is equal to kx. We know y is 40 this time. I don't know what k is. I know that x is 15. So to get k by itself, I'll divide by 15, which will cancel it. Divide 40 by 15. And that is 2.6 repeating is equal to k. So now I have a value for k. So the second part of this says find y if x is equal to 25. So I don't know what y is, but I do know what k is and what x is. So y is equal to 2.6 times my value for x, which is 25. So y is equal to 66.6 repeating. Okay, I hope that helps. Really remember, direct variation is just that when one of our values changes at a constant rate, the other value changes at a constant rate. So really we're looking at this kind of graph of some sort when we're looking at direct variation. So go ahead and check that out, and we will see you soon. Bye-bye.